Okay, we're almost near the top of the hill. First, we're going to talk a little bit about the geology. If you were here, I would have you take a look at this rock, reach out, touch, and feel it, and you could feel how coarse it is and start to see the sand that is inside this rock. So this is sandstone. And the sandstone was laid down in flat, horizontal layers along a beach somewhere. And so about 300 million years ago, this was sand at the beach. And as you look at these layers, you can see some of them aren't horizontal. You come in, you can see almost swooping angled lines. And you can start to wonder, well, didn't you just say they were laid down in horizontal layers? But what this is after the water level, the ocean level dropped, this sand turned into sand dunes. And the wind was blowing over the sand dunes, and we can see the direction of travel is going up along these lines. So you can see the wind was blowing in that direction, laying down and piling up the sand as it blew. These lines are called crossbedding, and it can show us that, one, that this was dry ocean and there were sand dunes here, and we can also tell the direction of the wind. The wind was blowing up into this direction at that time. Now also, North American plate, when we were studying Pangea and plate tectonics, we know that this North American plate, at the time that this was an ocean, was actually down around where the equator is. So it's moved quite a bit. But as we take a look at the rock, we can start to unfold the history. And notice we're at the top of the hill where the sand is. Later we're going to see a different type of rock called limestone down at the bottom of the hill. And we'll be talking about what does that tell us too. So we've gone up a little higher, and now we're looking at underneath, let me step back a little, underneath an overhang. And if you look close to those rocks, you can start to see like little holes, little honeycombs inside those rocks. And notice that almost some of the rock is missing. The question would be, how does this happen? Why would this happen? And how do these shapes end up being here? So you got to realize that this is, even though it's sandstone and it's really hard, dense rock, water still moves through these rocks. And as the water moves through, some of the compounds that hold the rock together can dissolve in the rock, and those are salts that were sort of lime and calcium salts that were holding this rock together, cementing it together. And as they dissolve, the rocks will slowly break apart, and we'll get a real fine sandy sediment that comes out of it. Also, there's times when that salt crystal, as the water dries, forms a crystal layer on the rock, and as it crystallizes, it gets bigger and bigger and will pop chunks of the rock off. So we often get this very characteristic honeycombing in that situation where that salt weathering is taking place too. So as the water moves through the rock, the parts of the rock that are more easily dissolved will no longer hold on, and slowly over thousands and millions of years will start to fall apart. And the more resistant rock stays in place. And so we get these scalloped edges. The water is moving farther and farther back as the rock disappears, and so it gets these scalloped edges. And if we came here during a really wet time, we could probably see right underneath the rock, you can see that layer down below where water is moving right through there and helping dissolve and create that opening down below. And slowly more and more chunks will continue to break off. If you look at the ground, it's kind of hard to see in the light, but you can see there are chunks of rock that have fallen off from the top and are now down below, but there's still a lot of empty space because this weathering took place over a long period of time with little bits dissolving and falling off over thousands and millions of years.